Hello everyone, let's go ahead and take a look at the limit comparison test. And again, we're trying to determine whether or not an infinite series converges or diverges. Now suppose that we have an infinite series a sub n that only has positive terms, and we also have an infinite series which you create called b sub n, which also only has positive terms. What we're going to be able to do with the limit comparison test is we're going to be able to take the sequence generator, take the ratio of that sequence generator, take the limit as n approaches infinity, and based upon the result we can actually make determinations about the infinite series that was given. So let's go ahead and take a look at what results we come out with. We can either come out with the limit as n approaches infinity of a sub n over b sub n equaling c, which is greater than 0, 0, or infinity. Now, if the ratio of a sub n over b sub n is equal to c, which is greater than 0 as the limit as n approaches infinity, then we know that both series, infinite series of a sub n and the infinite series of b sub n, are both going to converge or diverge. Let's take a look at an example. So if we have the infinite series from n is equal to 1 to infinity of 2n plus 1 divided by n squared plus 2n plus 1, let's go ahead and let this be equal to a sub n. We can use the limit comparison test, and let's say that we compare it to b sub n. B sub n in this case is just going to be 2n over n squared. I can just simplify that to 1 over n. And if I go ahead and take the limit as n approaches infinity of 2n plus 1 divided by n squared plus 2n plus 1 times it by the reciprocal of b over n, because I'm dividing by b over n, I'm multiplying by n, I can come out with the limit as n approaches infinity of this being equal to 2. And being that this is equal to 2, I need to now go ahead and determine what happened to the infinite series b sub n as we went from 1 to infinity. Now, we know that that particular series diverges. So then, since we have this particular result, then we know that this particular series is also going to diverge. Alright, let's take a look at another example here. This time, let's see what happens when the result is equal to 0. Now, if we know that the result is 0, and we know that the infinite series of b sub n converges, then we know that the infinite series of a sub n also converges. So here's an infinite series. It's the infinite series of the absolute value of sine n over n to the third. Again, let's go ahead and call that a sub n. Let b sub n be equal to 1 over n squared. So if I go ahead and multiply it by the reciprocal of b, notice the n squares and the n third will cancel to leave just one n in the denominator. If I take the limit as n approaches infinity, this is of course going to go to 0. Now we know that the infinite series of 1 over n squared converges. So therefore, we know that this particular infinite series that was given is also going to converge. Now, let's go ahead and find out what happens when the limit as n approaches infinity of a over n, a sub n divided by b sub n is equal to infinity. If that's the case, and we know that b sub n, the infinite series of b sub n diverges, then the same will also be true of a sub n. Let's go ahead and take a look at an example here. Here's an infinite series that starts from 2 going to infinity of 1 plus n natural log of n divided by n squared plus 5. Let's go ahead and let this be a sub n. Then for large values of n, what's going to happen then is that this is going to be very, very similar to just n natural log n over n squared, which is also going to be very similar to natural log of n over n, which is greater than 1 over n. So what we'll do then is we'll let b sub n be equal to 1 over n. If I multiply the sequence generated here by the reciprocal of b sub n, which is just n over 1, I come up with the limit as n approaches infinity of n plus n squared natural log n divided by n squared plus 5. If I divide every term by n squared, then what I'll come out with is 1 over n plus the natural log of n divided by 1 plus 5 over the natural log of n, which is of course going to be infinity. Therefore, since we knew that this particular denominator infinite series, or the infinite series of b sub n is going to diverge, then we know that the initial infinite series that we dealt with is also going to diverge. So you have three different results based upon the ratio of the sequence generators, and you take the limit as n approaches infinity. You're going to come up with a number, 0 or infinity, and based upon that we can go ahead and make some decisions about whether the infinite series, the given infinite series a sub n, is going to converge or diverge. Now, one of the things that we want to go ahead and take note about this particular limit comparison test is that remember that you're comparing the ratio of the sequences to determine whether the series converges or diverges. Okay, and it is often used when a sub n is a rational expression in n. So we'll go ahead and take a look at some examples as to how we can go ahead and use the limit comparison test, especially when a sub n is a rational expression in n, and it's going to be more difficult for us to compare it with another given series. Okay, so we'll take a look at some of those in class, and we'll take some further examples at that time. See you later. Bye-bye.